was this latest change in the status quo of that technological domain, was it a difference in kind, or is it just a difference in degree, but a bunch of good marketing and PR has made this suddenly much more salient? I mean, was there truly a breakthrough innovation that happened here, or are all the chickens coming home to roost on what was slow and tepid progress for a long time?
Yeah, it's a little bit of both, but I would say it's mostly a difference in degree. But there's a famous saying in deep learning that more is different, and a similar saying that scale is all you need. And so the basic architecture, the basic idea of a neural network goes back to the 1940s. So this is really sort of paying dividends from 80 plus years of research. And what changed is really, beginning in the 2010s, some breakthroughs with ImageNet, which is a image classification database. And before that, neural networks as a paradigm for AI had been sort of a backwater. People had been focusing on what are called symbolic approaches to AI, sort of more logical, Spock-like approaches to AI, things that you would probably relate to.
Yeah, so true.
The difference was those early neural networks just weren't deep enough. So neural networks sort of get stacked into layers. And what turned out is if you just throw a ton of layers, these hidden layers into the neural network, they suddenly can get really, really good at everything from image classification to, in the case of systems like ChatGPT, predicting the next word. And what happens early on is, yes, they sort of, early in their training, they get really good at identifying the statistical patterns in text. And so they're kind of doing a combination of memorization and autocomplete. But there's this other concept called grokking in the literature. And what grokking refers to is, in some of these models, what happens is you train them and they sort of reach a sort of a local minima. They sort of get pretty good, but they sort of stall out. And then suddenly, after 1,000 more training runs, something happens and they break through and they punch through to a deeper emergent level of understanding. And so one way you can think about this is, yes, there are people who will try to dismiss ChatGPT like systems as, they're just stochastic parrots, is one of the buzzwords going around. But there's really little difference, as far as I can tell, between prediction and understanding. And if you get good enough at predicting the next word, that requires you, or the model, to have some deeper understanding of what is generating those words in the first place. So if you feed it a bunch of examples of syllogistic logic, like all men are mortal, Socrates is immortal, Socrates is a man, at some point it will extract, as a more efficient representation of all that text, some concept of reason and causal reasoning. And now we know for certain that this is the case, because people have shown that with even just ChatGPT, that with the right prompting, you can get it to play at a human level of chess. And so obviously it hasn't memorized all of chess, because chess is like exponentially huge. But if you remind it of the game board and allow it to fix its mistakes, it clearly has the ability to reason. And so this is the real thing. It's a difference in degree, because we've scaled the systems up, but it's also a difference in kind, because these are the first times we've had systems that demonstrate sort of common sense reasoning ability. People are liking to think of these things as sort of knowledge engines that you're going to replace Wikipedia, but I think fundamentally they're reason engines, and we shouldn't count on them to know all the facts, but we can attach them to databases that store all those facts and do reasoning over those facts, and that's something that's genuinely novel, and shouldn't be conflated with older systems that are sort of based on sort of normal rule following.
Are ChatGPT, which is to say the conversation engine, and then Midjourney, which generates images, are they sort of the cutting edge representative platonic examples of the best of what this technology is capable of, or is there other stuff people should be paying attention to as they develop their schema for understanding it?
Well, I think there's been an explosion in these systems, and OpenAI, the company that released ChatGPT, which is sort of the first consumer version of this technology, so underlying ChatGPT, which is a chatbot, is a model, GPT originally 3, then 3.5, now GPT 4. That model has been available for a few years. I mean, I had access to it, I think, in 2021, and it was already extremely impressive. If not, it was pretty easy to use, but it wasn't a consumer product yet. They sort of, they were first to market, and I think that's worked out very advantageously for them. But other players in this space, including Google and Facebook/Meta, also have extremely advanced programs. Google many years ago bought a company called DeepMind, which at the time had the best AI lab in the world. They produced a number of important breakthroughs, like AlphaGo, the model that could beat human world champions at the game of Go. And so there's a number of other players on the what we call fundamental model side. And there's also some other players on the image generation side. I mean, Stable Diffusion. There's a few others that I'm not thinking of.
Well, a lot of this, a lot of people were focusing, like say 5 years ago, on the progress in chess, right? And so we've had chess AIs that are beat human players for a while. The most common one is Stockfish, but Stockfish is a combination of knowing a lot of opening theory in chess and then having like the ability to sort of search down the decision tree. Like, do I move my bishop over here or over there? And it will like rigorously search all those decisions.
Can you explain a little bit more clearly why that distinction is important? You know, you mentioned earlier that one of the signs that GPT is extremely highly progressed is that it's able to play a human standard of chess, but we've had programs that can defeat grandmasters for a very long time. What is the difference there, and why is it so interesting and important that it's able to do well enough in chess?
Yeah, it's surprising because it hasn't been trained explicitly to learn chess. Mm-hmm. It's been trained to predict the next word. And so the fact that it's picking up on all these other abilities that sort of come along, ride along with the power to reason and think, is what makes it remarkable. So in the case of Stockfish, you know, it's not that impressive to brute force search all the chess moves that you could make. What's more impressive is to play chess the way humans play chess, which is humans don't, sit there and calculate every possible move. They sort of have patterns, heuristics, sort of understandings of opening principles and broader theories. They have a deeper sort of structural understanding of the game, and that guides their how they play. And it's hard to program that in an old school way. It really has to be learned, and that's what AlphaZero did. So AlphaZero is the chess playing robot, and the very same model was used to do AlphaGo, which played the game of Go. And then there's also AlphaFold, which shocked the world several years ago by blowing the competition away in a protein folding problem. This is a long-standing problem of how proteins, there's about 20 proteins that matter for most of biology, how they fold up in response to all kinds of chaotic electromagnetic activity and so forth. It seemed like an intractable problem, and really all that took was throwing a huge neural network and a lot of training data, and sort of stepping back and letting the black box figure it out.
So one way of understanding this might be in the kind of 2010s, we got very, very good at taking this neural network architecture, applying it to massive amounts of data, and figuring out the deep structure of some question of chess, of Go, of protein folding, of detecting terrorism. That was a lot of the original funding for this came from DARPA and DoD. But what's remarkable,
has been.
It tells all this time.
Yeah.
But what's remarkable about this is what we did with language, right? Heidegger says that language is the house of being, and we've basically proved him empirically correct, because it turns out that if you take a neural network and you make a large language model, you train it on the corpus of all human speech, that you've basically trained it on the world. And this has created this kind of general purpose thing. So, you can use ChatGPT to play a game of chess, and then you could ask it and it will play a game of chess. And then you can ask it to write a limerick about its chess playing, and it will do that. And then you can ask it to write a computer program about something else entirely, and it will do that, and so on and so forth.
Yeah.
That's what's remarkable about it.
So much like there's going to be a Cambrian explosion of companies that are trying to take advantage of this technology, there has been a Cambrian explosion of takes.
Yes.
Some hot, some cold on the topic of AI. And that's largely what we have you guys here to talk about today. There's so many different directions that we can go on this. I think we should start with some of the most extreme claims that are made, which is this is HAL 3000. The AI is going to become a killer robot and kill me and kill everyone else. What say each of you? Is that something to be concerned about?